Okay, guys. So welcome to the sixth session. This is going to be the very beginning of starting to actually create iOS apps with UIKit. The first session we're going to dedicate it to a concept introduced by Xcode many years ago called storyboards, and we're going to talk about them. We're going to see from the concept of UIKit what a view controller is, what the life cycle of an app is, which actually resembles a lot to Android development as well. We're going to see what outlets and actions are, and eventually we're going to see what are the pros and the cons of using storyboards. So when you create an app, it will usually create a couple of delegates. One called the app delegate, which actually controls the life cycle of the whole application. You can actually invoke operations and make things happen from different methods here that will allow you to just control certain behaviors depending on certain points of the life cycle of the app. We also have something called scene delegate, which is similar, but it actually is assigned to a single and specific scene. In this case, the scene is basically a set of windows and controllers where a presentation layer is happening at the same time. But this concept is actually going to be touched later on when we start doing things a little bit more programmatically. We also have the concept of view controllers. The view controllers are the single block of UI that you can create for screens or even fragments of a single screen at a time. And then we have the concept of storyboards. In this case, storyboards are where you are a way to basically draw and drag and drop stuff as in order to build a UI by using a graphic interface. This is actually called an interface builder. Whenever you open the storyboard, this is called the IB, interface builder. And you can actually open this storyboard called main as source code, and you will be able to see that underneath, this is just XML code. Xcode doesn't really encourage you to write this XML code yourself because it's actually very cumbersome, complicated, and it's not very well documented, to be honest. So Apple encourages you to use the interface builder that they created so that you can just literally drag and drop stuff and in a very comfortable way write your own user interfaces. So in this case, we have a single label here. It's actually centered. If we go ahead and run the application, we are going to see exactly that. Why? Because if we go to the what is called in Android development manifest, this is actually called the info file, which is also a manifest. You are going to see that this has certain configuration, and it's talking about the scene configuration, but there's actually a place where you can see we are actually targeting to use this main storyboard. In this case, we're going to find it on this info file here, which is the manifest of the project itself. So let's see real quick. They have moved this so often that it's very easy to lose track of it. Actually, look, it's here. It's called the main storyboard file base name, called main, which means basically when it runs the app for the first time, it will look for a storyboard called main. And from then on, this storyboard is the one responsible of handling what is displayed on the screen. In this case, if we go to the main storyboard, we're going to see we have a single view controller. This is actually a canvas where you can we can drag and drop even more view controllers, which can represent different screens across your workflow in the app. And you will see an arrow entering this screen. This arrow means this is the very initial view controller that will be displayed whenever you run the app for the first time. And you can see there's a checkbox here called is initial view controller. which means exactly that. That is going to be the very first view controller that's going to be displayed whenever you run the app. So if we actually uncheck it, the error will disappear, of course, because now that's not the initial one. So we're going to keep it as initial, and we're going to start working on top of that one, which is a single view controller. And this is it. We have a view controller, which is what we mentioned before. A view controller is a single UI block that has a life cycle and will allow you to represent either screens or fragments in your application. Something great about this is the fact that whenever you use storyboards, there's a connection between whatever view controller you have here and the code that actually controls the behavior of your app. In this case, we have this view controller. And when we go here to this little icon, we're going to see that there's a class associated to this. So this view controller actually is not just a regular UI view controller, which is this. If we remove this, actually, the class here, we're going to see, it will say it's a UI view controller because it doesn't have an object associated to it that is a child of this class. It's just literally an instance of this class. But since we want to behave, we want to control the behavior of this view controller in a custom way, we create a child class of this UI view controller and say, this view controller is actually not a UI view controller, but our custom view controller. That way, whenever we run this view controller, this class here that inherits from UI view controller is going to be the one responsible of controlling the life cycle of this screen here. So that means, for example, let's talk a little bit about the view load. View load is possibly the most important lifecycle event of a UI view controller because it's run every single time a view controller is built, but it hasn't been displayed yet. So many things usually happen here. For example, if you want to load information, data, so that you can display some data on your app, this will actually usually happen here because you want to start loading data before it starts rendering, building the UI blocks of your application. So whenever we want to run something here like a load, we can say load data or something like that. And eventually you will use this data to populate information on your UI. So let's actually run an example here and see how this will actually work. Because if we print some information here, say loading data, and then we expand this icon here in order to see the console, this has to be enabled because this right side is the console where you will see all the logs. If we run the app, we're going to see loading data because since we have this view controller being displayed at the very beginning, and the view controller is actually associated to this view controller, basically it's going to run the view load here, and it will just print the log as it just did. Another important event of the life cycle is whenever it already displays the screen. So sometimes you may want to start certain operations whenever it has already presented the UI. So in this case, we will use a method called viewDidAppear. And it actually takes a parameter called animated, which you can use at your own sake. But in this case, what we are going to do with this is called the super method of this UI view controller and pass the same argument that we took from the parameters. In this case, if we print the log, we're going to say view just presented. If we run again, we're going to see the first log actually was loading data because viewDidLoad was called first, and eventually viewDidAppear was called afterwards whenever the application actually, the screen was actually presented. and that's why it was printed second. Okay, so this is about event lifecycle events. We actually have more. We can say you will appear or you will disappear in case we want to run operations whenever we're going to dismiss certain screen or something like that, and many other options that we can subscribe to depending on the hierarchy and the workflow of our app. So it is important to understand that we have access to these methods, and we just have to implement them because they are actually created in the very beginning on the UI view controller, and all we have to do is call override in order to override the functionality on this child class. And that's it. Just make sure to always call the super methods, because it will need to understand, it will still need to comply to a parent UI view controller, because whenever you run these parent operations, some other operations will actually be executed that will allow your app to behave smoothly. So it's just important for you to always call these super methods. Okay, so let's talk about a bit about drag and dropping elements. So let's talk about the elements we have at our disposal here. Okay, so we have two labels, as you just saw. We have buttons. We can just drag button, say we want a button to load information, which is a poor experience, but for the sake of displaying connection, let's do it. Okay, we can change the label here. And center it because this provides certain guidelines. We also have several styles of buttons. We have pull downs, segment controls, text fields, which are going to be important for us creating the functionality of searching certain characters. Remember, we're going to write an application that will allow us to explore and search for characters from Marvel Comics. This actually can have a placeholder called search. We have sliders, switches, even activity indicators. For example, we could use an activity indicator to provide feedback to the user and understand that something is happening. We have stacks, vertical and horizontal. We have table views. Table views are extremely important, and we're going to talk about them later on in later classes. But they're actually very commonly used in order to build certain user interfaces. In this case, we're going to actually use a table view because we need to provide a way to list the different characters whenever the user searches for one. We have images view, which is going to be useful in order to display the images of our characters. Collection views for grids. Text views, which are also called text areas in our technologies. Scroll views to providing scroll behaviors to certain custom objects that don't have scroll view capabilities by default. And many other things like even maps. Metal is for very advanced graphics. Sync kit is for 3D graphics. Sprite kit is for 2D graphics. Many things more. And this actually goes back to some frameworks that I have mentioned before in the first session that will allow us to create very custom experiences to our apps depending on what our app is targeting. Okay, so let's talk a little bit about how we can connect these to our code, because right now this is just a bunch of objects that we don't have a way to interact with through this view controller. So in order to interact with this, we are going to need to create a certain bridge between this presentation layer that is actually written in XML and this script code that we are already familiar with. In order to make this happen, we are going to use this icon here and add an editor on the right. And then it's going to replicate the exact same thing, but we don't want that. We want to use this right side to open the view controller here And with this view controller, we are going to have side by side the canvas, the storyboard, and the script code. And after this, what we're going to do is select certain field. Let's say, for example, this search field. We're going to press Control, and just by dragging, it's going to draw a line for us that will allow us to create something called an outlet. And we can give it a name. We can say search field, and we can tap on Connect. And that's it. We already have an outlet. An outlet is a bridge that is going to automatically create a reference to the XML code that will allow us to interact with this field as if it were created programmatically. And that's it. I just don't need anything else. I can just say, whenever we display this screen for the first time, I want to say this search field is going to have a text called write something here. Let's run and see what happens. It's actually worked. Whenever I presented this for the first time, we're actually interacting with this text field, and we are changing the text of this input, and that's it. It actually did it. So here we have it. It was super fast and easy to just drag and drop a few elements and interact with them. Now, this is an outlet, and this will allow us to interact with the storyboards through a reference. But what about whenever the user interacts with our application? How can we capture those events and understand some interaction is being received from the storyboard? So in that case, we have a concept called actions. So whenever we select a button, for example, that can actually trigger actions, we can control and drag and drop again. And this will allow us to create either an outlet of the button so that we can interact with it the same way we just did with the UI text field, or we can create an action that will allow us to create an event. Say, for example, user did have low data. And then we're going to say connect. It's going to create a method for us called with the same name I just provided it. And it's going to say it's an IB action, meaning this is going to be an event received. It's going to be a method invoked whenever this actually happens. In this case, we're talking about a click action, a tap action. So we're actually going to be able to see that, because if we tap on this button here and we go to the inspector, we're going to see there's a connections inspector here. If we click it, we're going to see there's actually a method called user did tap load data of the view controller that is connected to the event push up inside. So whenever the user touches and releases the finger while being inside this button, is going to trigger this method. And being that said, we're going to say, okay, print something here. Load data was tapped. And we can also, let's say we're going to change the text field name, search text field, to loading data. Then run again. So if we tap on load data, first of all, we're going to see a log. Here it is. And second, it says loading data because we just modified the text of the search field whenever this was called. So here it is. This is the way of interacting towards the UI. We actually can alter in any way whatever element we have from there by creating IB outlets, which will create references for us in order to be able to interact with them in any way. And actions are actually the opposite. This is a way for the interface builder to interact with us and call certain actions whenever the user interacts with the presentation layer, in this case, the storyboard. And this is it. This is what IB audits and IB actions are about. As you can see, they start with IB, which stands for Interface Builder, because whenever you're working with storyboards, this piece of the IDE is actually called the Interface Builder. So that's it for now. Let's see, what are we missing from the agenda? Okay, yeah, finally, pros and cons of using storyboards. So the thing about all this is the fact that whenever you write a very simple user interface like this, when you see what is actually being version controlled, it's actually a bunch of code that is just like quite a lot for something quite simple. And that's actually something we as developers don't like too much, because it won't provide us a way to have a graceful experience while handling a version control. Plus, we don't really have a way to interact with this from the code perspective. So that's why many developers using UIKit prefer to create all of this programmatically without using the interface builder, and create literally all of these we just saw on the storyboard by using script code. And that's actually what the next section is going to be about. We're going to try to create an interface that will allow us to write everything from scratch with script code using UIKit. And despite it will be a little bit more cumbersome, it will give us more control. So that's the thing about using storyboards. Storyboards are cumbersome for version control and for being able to interact with the code directly. But at the same time, it will give us a very easy experience to handcraft many things ourselves very easily, very fast, very efficiently. But the thing is, you basically will use a lot of control, and that's where writing user interfaces with UIKit will come in. User interfaces with Swift will certainly be a little bit harder, but will give you more control. But the problem is, you will end up finding yourself across a lot of boilerplate code very often. But it's anyway the best way to do it. So that's why we'll explore it in the next session. So yeah, for now, I just want to give you some space, guys, in order to ask any questions you may have. But that's it for now. This is UIKit with storyboards.
One question. Are iOS apps capable of having multiple entry points? Android, for example, allows that.
And multiple entry points, what do you mean with that?
Multiple places where a user can enter the app, as in multiple launcher icons, or for example, entering via notification rather than via the app icon itself.
Yeah, it
Or
does.
via settings.
And actually, that's where these scenes come in. Whenever these scenes are being composed, you will be able to deliver different scenes depending on the entry point. So with storyboards, this is actually something you don't have too much control over, but you can also subscribe and manifest certain entry points to target different storyboards depending on the experience you want to provide. But yeah, scenes are the answer to your question. Through scenes, you can subscribe to different entry points and deliver different experiences. Yeah.
Okay.
Any other question? Nope. Okay, guys. So this was it. This is UIKit with storyboards. We're not gonna stick to it. It may have seemed too easy, and it's important for you guys to understand how this behaves, because this will actually be a base knowledge of what we're gonna be building on later on. But then we're gonna start writing this exact same thing by just using Swift code in the next session. So see you then. Thank you so much.
Thank you, Sergio. See you later.